Hello everybody. Today we're going to be going over Taylor series approximation. So let's look at this problem here. We have, using the second order Taylor series, approximate the square root of 29. And I'll round to the nearest 1/1,000,000, just for accuracy, I guess. And how this is going to work is we're gonna have to know what a Taylor series is. So f of x is going to equal, well, when we have a Taylor series, what we're going to do is we're going to have a function and we're going to approximate it using this series of things. So f of x is going to equal, and then we're going to use the center. This center is going to be the c in our equation, and this is how it's going to work. So we're going to have f of 0 times x minus c to the 0th over 0 factorial. Remember, 0 factorial is 1, and n factorial, like 4 factorial, is equal to 4 times 3 times 2 times 1. So that's just something good to know. And then it's going to equal, and we're going to add f prime of 0, which is the derivative of the function, and then you plug in 0, and then times x minus c over 1 factorial, and then now we're going to add again f prime of 0, and we're only using a second order, so this is the farthest we get to go. F prime of 0 times x minus c squared, and then we're going to put this over 2 factorial. So this is going to be our Taylor series approximation. So first things first, let's actually find our functions at these certain derivatives. So f of x, well, we're using the square root of 29, so we should probably use the square root function, so which is just a square root of x function right there. And our center needs like, because these derivatives here, I'll list them out here, f prime of x and then f prime of x. These are also going to be have square roots in them, so it is good to have a number that you could take the square root of. In this case, I'm going to choose that the center is equal to 36. Let me box that in blue real quick. So the center is 36. Now, when we take the derivative of the square root of x, we're essentially taking the derivative of x to the 1 over 2. And when you take the derivative of some power, you just move it over, and then you subtract 1. So now it's going to be 1/2 x to the negative 1/2. So let's write that down in the region. 1/2 x to the negative 1/2. And then now we take the second derivative. Let's have this function here, x to the negative 1/2. Let's move this negative 1/2 over and then subtract 1. We're essentially subtracting 2 over 2. So this is going to be x to the negative 3/2, and then negative half times the half is negative 1/4. So let's put that in the region too. Negative 1 over 4 times x raised to the, well, it doesn't matter about the parentheses necessarily. Now that we have all these, now we need to plug this into our center here. So f of 36 is equal to 6. F prime of 36 is equal to, well, this x to the negative 1/2 means 1 over the square root of x. So 1/2, 1 over 6 is just 1 over 6 times 1/2. And then this is equal to 1 over 12. So let's write that. 1 over 12. And then f prime of 36 is, well, we have 1 over the square root of 36 to the third. So all we don't need to evaluate 36 to the third. We just need to evaluate the square root of 36 and then raise that to the third power. So this is equal to 6 to the third power over 1, which is equal to 1 over 216. And then obviously we need to multiply this by -1/4, which is equal to -1/864. Type that into your calculator. So this is -1/864. And now we have everything solved. Now all we got to do is now we're just going to have to write out the Taylor series, and then we're going to plug in this 29, because in this case we want to approximate 29, not 36. So we need to actually plug in 29 and then evaluate the whole expression. So f of 0, or in this case we're not using 0 here, but this is for something called the Maclaurin series, which is where c equals 0. But in this case, our center is 36. So f of 36, which is 6, and then x minus c to the 0th is just 1, and then over 0 factorial, which is 1. So it's just 6 plus f prime of 0, or in this case, sorry, I'll keep referring to it as this, f prime of 36 is equal to 1/12. So now I will just be adding 1/12 times x minus the center, which is 36, over 1 factorial, so we don't need to worry about it. And then now, since we have a negative sign here, let's subtract 1/864 times x minus 36 squared, all over 2 factorial. In this case, 2 factorial is equal to 2 times 1, which is just 2. So we could just write it as 2 on the bottom. There. Now, all we have to do is plug in 29 to approximate this. So this is going to be 6 plus 1/12, and then 29 minus 6, so this is going to be -7 squared. And then we're going to subtract, well, this over 2, let's just simplify this to -1/1728 times -7 squared. And then what this is going to simplify down to, here I will use a calculator for this step, because you can definitely not do this in your head for sure. And then what you will get, let me type it in for a moment, 1/12 times -7 squared minus 1/1728 times -7. Sorry, hold on. I made a very slight mistake here. I meant to put not the squared here, and then -7 squared, and then this is equal to 5.38831. There we go. So that is that Taylor series approximation of the square root of 29. Now, let's actually plug into our calculator. Let me remove some of this work real quick. I even got rid of the square root of 29, but it's fine. I can just rewrite it. So, I know that our Taylor series approximation, so f of x is equal to the square root of x, and our Taylor series approximation, so our Taylor series of t of, we're using a second degree, so t2 of x is obviously was going to equal that huge function right there, but we don't need to write that down. What we need to do is we need to write down t2 of 29 was approximately 5.38831. And then now we just actually need to find f of 29, because f of 29, we're going to put that back into the function, and we're going to get the square root of 29, because that is what we're approximating in this one. So when you take the square root of 29, it's 5. It's approximately 5.3385.164. See, these are the similarities between these two here. Now, it is very good to note that if we use C as a base, if you use 25 as a base, it would have been a little more accurate. But in this case, I just said we can use 36 as the base. But traditionally, you're supposed to use C equals, whatever's closest to the function, and that you can actually plug in. So that's why we use 36, is because it's a very close square root, and it provides a decent approximation of the square root of 29. Anyways, I hope you liked the video. Subscribe, hit the notification bell, and good